So in this video, I'm going to be looking at introducing surds. So hopefully what you'll take away from this particular video is your ability to identify the features of a surd, identify and justify what makes a number a surd, and be able to simplify a surd under a radical sign. So just know that if I am talking about the radical sign, sometimes I might refer to it as the root sign. Certain textbooks and other resources will use these interchangeably as well. So just a few things here to note. A surd is an example of an irrational number in that the number cannot be expressed as a ratio of two whole numbers. So an example of an irrational number could be pi. If you're struggling to remember what exactly an irrational number is, I'd highly recommend going back to the task where I got you to categorize numbers or different types of numbers into a hierarchy, where you will have written definitions of different types of numbers down. So surds are represented by a root sign or a radical sign. So for example, what I'm talking about is that sign in particular. So examples of surds are the square root of 7, the square root of 5, the cube root of 11. This list isn't exhaustive, this is just a few examples. So examples of numbers that are not surds include the square root of 4, square root of 9, cube root of 8, and there's a few other examples. Actually, there's many other examples. If you're kind of trying to understand why exactly these numbers are not surds, just have a think about what a rational number is. Now, if it's still not coming back to you, that is completely okay. Hopefully, by watching this video and then doing the supplementary task that I've assigned, it will become a lot more obvious. So if we go into identifying the features of a surd, obviously the most important thing here is being able to identify the root sign, which I just highlighted in pink. So I'm just going to label that my root sign or my radical sign. The next important thing here to be able to identify is what we've represented with the letter N. So what this is actually called is our index number or our power. Now, if there is no index not power, degree. Just make my eraser smaller. So it could be called my index number or my degree. Now, if there's no index number or degree number given to you, it's implied that n is actually 2. So I'll just write that down here, and I strongly recommend you note it down somewhere. So for example, you'll see examples later on where the index is 3, for example, and then there'll be a number underneath that root sign. So we call the number where I've written an example of 50, we call that the radical. And basically the radical is any number written under the root. Now, it's really important here that you understand that radicals can be categorized into two categories. So the first is what we call a rational radical. And basically this is a number that can be expressed. So I'm just going to write can be expressed by a rational number. So highlight here that it can be expressed by a rational number. So for example, an example of a rational radical would be the square root of 4, which then equals 2. The second category we have is called irrational radicals. And this is when a number cannot be expressed by a rational number. As a rational number. So for example, this could be the square root of 3, which is an irrational radical. So just make sure you make note of this as well, because it will be really important in the future, especially when you're looking at key terminology for this particular unit. So if we move into simplifying surds, basically the theory suggests, or sorry, it doesn't suggest, it says that in order to simplify a surd, it means that we need to make the number or an expression under the radical sign as small as possible. So that's your biggest hint here, is to simplify a surd, you need to make the number or the expression as small as possible. You should aim to write it as a product of two factors, where one of the factors is a perfect square. So we know our perfect squares could be 4, 25, it could be 100. These are just some of the numbers we suggest using when you are trying to simplify a surd. And where possible, aim to identify the largest perfect square possible when you are simplifying a surd, so that then there are fewer steps for you when you are going to simplify it. So if we take a look at this first example that I've written, so I've written down that we want to simplify the square root of 40. So here what I'm going to do is sort of work through the process above in order to simplify the square root of 40 to its smallest or simplest possible surd. So a suggestion has been made that we should aim to write it as a product of two factors. So let's start there. So if I'm going to identify the factors of 40, they are 1 and 40, 8 and 5, 2 and 20, and then we have, of course, 4 and 10. So I'll just write these all as 1 times. All right, cool. So now that we've done that, the next suggestion says where one of the factors is a perfect square. So looking at the combinations I've written, we can identify that that contains a number that is a perfect square. So does that combination there. So then the next hint says, where possible, aim to identify the largest perfect square. In this case, the largest perfect square happens to be where our factors are 4 and 10. So it looks like I'm going to be using this. Now, regardless of what you use, which combination you use, except for 1 times 40, you will actually arrive at the same answer. The only difference is it will take you a few more steps to do that. So if we use 4 times 20, I'm going to rewrite the square root of 40 as the square root of 4 times the square root of 10. Now if I simplify each of these on their own, the square root of 4 does simplify to 2. Now the square root of 10, if I rewrote that in terms of, or as a product of two factors, unfortunately neither of them actually work out to be a perfect square. So it'll sort of just send you back into a loop where the smallest number you actually get is the square root of 10. So I'm just going to write 2 times the square root of 10. What I encourage you to do now is actually pause the video and have a go at simplifying the square root of 40 using either 8 times 5 or 8 and 5 as your factors, or 2 and 20 as your factors, and check and see whether you also get 2 times the square root of 10 as your final answer. Now, if you're wanting to use your CAS to help you verify that your answers are correct, I strongly encourage you to do that. I would suggest that you go to your calculator, If you click the control button and then that button where it has x to the power of 2, that will actually give you the root sign. Now, remember I said where there's no index provided, it's implied that n is actually 2, or our index or our degree is 2. So in this case, we don't have to worry about anything else. I'm just going to write under the root sign 40 and then click enter. What you can see here is that the calculator has now simplified the square root of 40 to its most simplest form, which is actually 2 times the square root of 10. So you can see here that we are correct. Now, if you use any other factors such as 8 and 5 or 2 and 20, you should arrive at the same answer as well. So hopefully now you are feeling a little bit more comfortable about identifying the features of a surd, and you can explain what makes a number a surd, and you can simplify a surd to make the number under the root sign or the radical sign as simple as possible. Now, if you're not overly confident, that's completely okay. The task that I have set up and the subsequent worksheets that I've got set up as well will give you ample practice to practice simplifying surds. So hopefully by the time you get to moving on to addition and subtraction of surds and multiplication and division, of Surds, you're not struggling too much with simplifying them as quickly as possible.